You know how it is, you want to get the big picture, understand the stuff that's really shaped the last, half century. But who has time for weeks of reading?
Right.
So that's what this is all about. It's your fast track to the key insights, those aha moments, without getting totally bogged down.
Yeah, cutting through the noise.
Exactly. Today, we're diving into 25 landmark innovations and policy shifts. These are things that have really defined the last 50 years.
And the common thread we've sort of pulled out, looking across all this material, is really about amplifying human potential.
Okay. How so?
Well, think about it. Lifting people out of poverty, expanding knowledge, boosting productivity, tackling huge global challenges. These innovations, each in their own way, they've all pushed that forward.
So we're looking at this collection of info that kind of pinpoints these key moments and tries to figure out why they work.
Exactly. It's not just about the initial bright ideas. It's the alchemy of making it actually happen.
Right, the execution.
Precisely.
Yeah.
And our sources point to some common traits in these success stories. Things like having a really clear vision.
Knowing where you're going.
Yeah, and deeply understanding what people actually needed, the unmet needs. Plus, a willingness to experiment, iterate, fail sometimes.
Learn as you go.
Definitely. And making sure incentives line up and just sheer perseverance, sticking with it.
So we'll touch on both the idea and the messy reality of getting it done.
That's the plan. The spark and the hard work.
Okay, so 50 years, 25 big shifts. Where do we even start? The material we've got kicks off with some major economic transformations. China's economic reform and opening up in 1978, that feels huge.
Oh, it was massive. And what's fascinating isn't just the scale, but the fundamental change in thinking. The idea was moving from that rigid, centrally planned economy towards something much more market-driven.
Yeah.
And they started with these special economic zones, SEZs, think Shenzhen.
So these weren't just random spots on a map. There was a strategy.
Absolutely. The sources highlight that these SEZs were like magnets. They offered things like tax breaks, less red tape.
Ah, okay. Making it attractive.
Exactly. Actively courting foreign investment. It created this incubator environment for new ideas and capital.
But getting it right, the execution must have been tricky.
Crucial. Deng Xiaoping's leadership was key here. Setting up the pilots, clear guidelines, encouraging partnerships with foreign firms, and then, importantly, gradually scaling up what worked in those zones to the rest of China. It wasn't overnight.
And that wasn't the end of the story for China and the global economy, right? Fast forward to 2001, and they joined the World Trade Organization, the WTO.
Right. If you connect the dots, joining the WTO was about fully plugging into the established global trade system, operating by the same set of rules as everyone else, basically.
What made that such a big deal?
Well, WTO membership brought real benefits. Lower tariffs, for one, making their exports cheaper.
More competitive.
Yeah. And a system for resolving trade disputes that adds stability. Plus, huge market access worldwide. It really fueled their export growth and helped bring in technology and know-how.
And it took a while.
Oh, yeah. The info we have points to 15 years of tough negotiations.
Yeah.
Big commitments on things like tariffs, protecting intellectual property, opening their own markets.
Okay, so massive economic shifts. Let's pivot to something maybe closer to home for a lot of listeners. The Vanguard 500 Index Fund. Launched way back in '76. Doesn't sound as dramatic, maybe, but wow, the impact on personal investing.
It's incredible, isn't it? The insight there is the sheer simplicity and power of it. Instead of paying managers to try and beat the market by picking stocks.
Which is hard and expensive.
Exactly. This fund just mirrors the S&P 500, a broad slice of big U.S. companies, passively.
So no fancy analysts, just tracking the market.
Right. And because you cut out that active management layer, the fees are dramatically lower.
And those fees really add up over time, don't they?
Massively. Compounding works both ways. This was about making wealth building more accessible, challenging that old idea that you had to pay high fees, proving low-cost market exposure could win long-term for the average person.
And John Bogle, the founder.
Yeah, Bogle set up Vanguard with this unique structure where the fund investors actually own the company, sort of at-cost pricing. That locked in the low fees.
Okay, so economics, personal finance feels like a natural jump now to, well, technology. That's another massive driver of change these past 50 years. Where do we start there? Microprocessor revolution, maybe?
Yeah.
Early 70s?
Definitely. That's the bedrock for so much else, the fundamental idea. Squeezing the whole central processing unit, a computer's brain, onto one tiny silicon chip.
Which sounds incredibly difficult. Why was that such a game changer?
Cost and size. just plummeted. Things that filled rooms and cost a fortune suddenly became small and affordable.
Right.
That opened the door for personal electronics, factory automation, and, yeah, the PC. Intel's early chips, the 4004, the 8008, 8080, they were pivotal. They also helped standardize things, which pushed costs down even faster.
Which leads us right to the IBM PC in 1981. That really kicked off the PC era proper, didn't it?
It did. And IBM's genius move was bundling readily available, off-the-shelf parts.
Not building everything themselves.
No, and combining it with an open architecture, all under their trusted brand name. The idea was a versatile machine for the office and home.
So open architecture means?
They basically published the technical specs. They outsourced the CPU to Intel, the operating system MS-DOS, to a little company called Microsoft.
Huh, yeah. Heard of them.
Right. And by opening it up, they invited others to make compatible hardware and software. That
No.
created this huge ecosystem.
And drove prices down, the whole PC clone phenomenon.
Exactly. That openness was key.
Okay, hardware's moving fast. But for computers to talk to each other, for the internet we know, needed a common language, right? TCP/IP standardization, that was 83 to 95.
Spot on. Before TCP/IP, networks were like isolated islands. Couldn't really communicate. The idea behind TCP/IP was a single, universal set of rules, a protocol for how data gets chopped up into packets and sent across networks.
Like a universal translator for data.
Perfect analogy. It made global data exchange seamless, scalable, reliable. Government and academia pushed it, phasing out older networks like ARPANET, mandating TCP/IP. By the mid-90s, it was the standard.
And building right on top of that foundation, the World Wide Web, 1991. It's easy to forget how revolutionary that was, making the internet usable for, well, everyone.
It really transformed the internet from a tool for academics and researchers into this global information space. The key ideas: hyperlinks, connecting documents, HTML to format them, URLs to give them addresses, all navigated with a browser.
So not just connected computers, but connected information. Anyone could potentially browse it.
Exactly. And Tim Berners-Lee at CERN, huge credit to him, not just for inventing it, but for making the protocols open source. That decision fueled incredibly rapid growth. The browser wars helped make it user-friendly too.
But as the web exploded, finding anything became the problem. Enter Google search, 1998.
Right. The real magic there was the PageRank algorithm. The core idea wasn't just counting keywords on a page. It was analyzing the links between pages.
Okay.
Think of a link from one site to another as a vote, an endorsement.
So if lots of important sites linked to a page, it ranked higher.
That's the basic principle. It delivered way more relevant results than anything before it, made Google essential, fast. Larry Page and Sergey Brin at Stanford figured this out, built the tech to handle it, and then figured out how to pay for it all.
Which brings us neatly to AdWords, around 2000. Online advertising seems like such a fundamental part of the net now.
It really is. The core idea, an auction system. Pay-per-click. Businesses bid on keyword people search for. Their ads show up next to the results. But crucially, they only pay if someone actually clicks the ad.
So way more targeted and measurable for advertisers.
Absolutely. Direct ROI tracking. And for Google, a brilliant way to make money from search without, initially at least, compromising the main results too much. They built this self-service platform, real-time auctions, opened it up to businesses big and small.
Okay, so while Google was helping us find stuff, Amazon, starting back in 95, was changing how we buy stuff online.
Jeff Bezos. The vision was just huge. An online store selling everything. But it wasn't just selection. It was this relentless focus on the customer.
What were the key ingredients there?
Massive selection, obviously. Convenient shop, anytime, anywhere, low prices, and then increasingly super fast delivery.
Right. The logistics must have been immense.
Totally. Bezos famously just kept reinvesting profits back into the business, building fulfillment centers, developing recommendation tech, and of course, Prime membership. That 2-day shipping was a game changer.
Then, 2007, another landscape shift. Apple's iPhone. Not just a better phone, but something else entirely.
Exactly. It wasn't incremental. The idea was blending a phone, an iPod music player, and an internet device into one sleek thing with that revolutionary multi-touch screen.
It really redefined the whole mobile experience, what a phone was.
Absolutely. It became the hub for your digital life, not just calls. And it kicked off the whole app economy. That ecosystem was huge. Apple's tight control hardware, software, the App Store was central to that success.
And speaking of ecosystems and infrastructure, Amazon Web Services, AWS, cloud computing, taking off around 2006.
Yeah, another fundamental shift. The core idea: offer computing resources, processing power, storage databases as utilities. On demand, over the internet, pay for what you use.
So businesses didn't need their own huge server rooms anymore.
Exactly. No massive upfront costs, much more agile, experiment faster, scale easily. Amazon basically took the infrastructure they'd built for their own retail empire
Right.
and turned it into products. EC2 for compute, S3 for storage, opened up the APIs for everyone else.
Okay, moving maybe a bit more behind the scenes, but vital for developers. Containerization, Docker, around 2013.
This one's clever. The idea is packaging an application and all its dependencies, libraries, settings, everything it needs to run into a single lightweight container.
And why is that a big deal?
Consistency. That container runs the same way everywhere. Developer's laptop, huge cloud server, doesn't matter. It massively simplifies deploying software, uses resources more efficiently, and really enabled modern practices like DevOps. Docker, built on existing Linux tech, made it easy to use, and that led to things like Kubernetes for managing lots of containers. It solved the, well, it works on my machine problem.
We've talked a lot about company tech, but open source software, that's another huge threat, isn't it? Linux 1991 is the classic example.
Absolutely. The idea is almost deceptively simple. Share the source code freely, let anyone use it, modify it, distribute it, usually under specific licenses.
So like global teamwork on software.
Pretty much. It taps into developers worldwide, leads to incredibly fast innovation, really robust software, often faster than closed proprietary models. Linux, started by Linus Torvalds under the GPL license, now powers vast chunks of the internet, cloud infrastructure, enterprise servers, with big companies like Red Hat and IBM backing it commercially too.
Then shifting to the social side, social media platforms. Facebook, 2004, is obviously the giant there.
Right. The core concept. Create online spaces for people to connect with friends, family, share updates, build communities.
And the more people joined, the more useful it became. Network effects.
Exactly. Classic network effects. Each new user adds value for everyone already there. And of course, they figured out how to monetize those huge audiences through highly targeted advertising based on user data. Zuckerberg started it at Harvard, it spread to other universities, then went public. Changed communication fundamentally.
And finally, in this tech whirlwind, deep learning and transformer models, really taking off since maybe 2017, transforming AI.
Yeah, the big breakthrough with transformers is how they handle sequential data, like language. They use this thing called self-attention.
Self-attention.
It lets the model weigh the importance of different words in a sentence when processing each word. Instead of just going word by word, it looks at the whole context simultaneously. Understands relationships. That parallel processing ability was key.
So this is the tech behind things like ChatGPT and other recent AI leaps.
It's foundational. Google's attention is all you need paper in 2017 was pivotal. Led to models like BERT, the GPT series, huge jumps in understanding and generating language, computer vision too. It's really fueling this current AI wave.
Okay, wow, that was a lot of tech. Let's shift focus now. Innovations with maybe a more direct societal or scientific impact. Mobile money seems like a great place to start. M-Pesa, Kenya, 2007.
Truly transformative. Addressed a massive unmet need. The core idea, let people do financial transactions, send money, pay bills, using just a basic mobile phone. No bank account needed.
Which is huge in places with limited banking infrastructure.
Absolutely. Financial inclusion for millions who were previously unbanked. Made it safer, more convenient. The key was a partnership between Safaricom and Vodacom, using the simple menus on basic phones and building this massive network of local agents for cash in, cash out. Genius, really.
Then there's blockchain and Bitcoin. 2009 certainly caused a stir.
Definitely disruptive. The core idea. A decentralized, cryptographically secured digital ledger. Allows value transfer directly between people, no need for banks or payment processors as middlemen.
So enabling trust without a central authority.
That's the goal. Strong cryptography, distributed ledger. It creates transparency and verifiable digital scarcity. Satoshi Nakamoto's white paper laid it all out, and the Bitcoin software incentivized people to maintain the network through mining rewards. Still evolving, obviously.
Okay, shifting to biology. CRISPR-Cas9 gene editing, around 2012. Sounds like science fiction almost.
It felt like it. The core idea was repurposing a natural bacterial immune system enzyme into a precise, programmable tool for editing DNA. Like molecular scissors, you can guide to a specific spot in the genome to cut, paste, or modify genes.
So editing the code of life with incredible precision.
Pretty much. Compared to older methods, CRISPR was simpler, faster, more flexible, made gene editing accessible to way more researchers. The work by Jennifer Doudna and Emmanuel Charpentier was absolutely groundbreaking, opened up a whole new era.
And speaking of biology with rapid, massive impact, mRNA vaccine technology proved itself spectacularly in 2020.
Unbelievable speed and efficacy. The core concept. use synthetic messenger RNA to tell our own cells to make a specific protein from a pathogen, like a virus spike protein. That protein then triggers our immune system.
What made it so much faster than traditional vaccines?
Because it's based on a genetic template. You don't need to grow the whole virus. Design and manufacturing are much quicker. Plus, they showed incredibly high efficacy. The platform can also potentially adapt faster to new variants. Years of research went into how to deliver that fragile mRNA into cells. Biotech, Pfizer, and Moderna nailed that using lipid nanoparticles.
Okay, changing gears again. How we get around. Electric vehicles! The commercial revival really got a jolt from the Tesla Roadster in 2008, didn't it?
It really did. The Roadster's goal wasn't just to be an EV, but a desirable, high-performance sports car, shattering that old image of EVs being slow, clunky, compromising.
Yeah, definitely made EV seem cool.
Exactly. It overcame that stigma. And it spurred huge innovation in batteries, powertrains, charging infrastructure, Tesla's direct sales model, reinvesting heavily in R&D.
Yeah.
All key parts of their impact.
And tied into sustainability, solar PV. The massive cost drop and scale up, especially in the 2000s and 2010s.
Huge story. The driver was relentless mass production of silicon solar panels, pushing down the cost per watt year after year.
And they succeeded dramatically, right? Costs plummeted.
Incredibly so. Economies of scale, better manufacturing, global supply chains, especially huge manufacturing in China, brought costs way down. Solar is now cost competitive with fossil fuels, in many places grid parity. That's why installations have just exploded globally.
Okay, something many of us just take for granted now. GPS. The opening up for civilian use, that was gradual, 83 to 96.
Right. It started as military tech. The decision to let civilians use the unencrypted signals for navigation and timing that had revolutionary consequences down the line.
Hard to imagine life without it on our phones now.
Completely ubiquitous. Transport, logistics, farming, surveying, endless consumer apps. It's foundational. Reagan's authorization was an early step, but getting rid of selective availability, that intentional fuzzing of the civilian signal in 2000, made it much more accurate and useful for everyone.
Let's talk about tackling poverty directly. Microfinance. The Grameen Bank model, starting around 76.
A really important innovation. The core idea. Tiny loans without collateral, mainly to poor women, to start or grow small businesses, empowering self-sufficiency.
And the repayment rates are famously high.
Surprisingly high, yeah. The Grameen model, pioneered by Mohammed Yunus in Bangladesh, uses peer groups. Social accountability acts like collateral. It proved you could lend to the very poor, get repaid often over 95%, and make a real dent in poverty.
And finally, back to pushing boundaries, literally. SpaceX and reusable rockets, Falcon 9 landing successfully in 2015 was a huge moment.
Absolutely game-changing. The core idea. Land and reuse the first stage booster of an orbital rocket. Traditionally, those were just thrown away after one use.
Which sounds incredibly expensive.
It was. Reusability slashes launch costs by more than half.
Yeah.
It enables launching more often, more affordably. SpaceX just kept iterating, testing, failing, learning, until that first successful landing, a massive turning point for space access.
Wow. Okay, that was quite the tour through 50 years of change. Looking back across all 25 of these, are there some big takeaways? Recurring themes?
Absolutely. I mean, what jumps out is the power of combining that bold, clear vision with just relentless, meticulous execution.
Right, the idea and the follow-through.
Yeah. And they all, in their own ways, were trying to solve fundamental human needs or push boundaries, do something that seemed really hard, maybe impossible.
And for everyone listening, understanding these past breakthroughs, it gives you a kind of lens, doesn't it, for thinking about how big change actually happens and maybe how future breakthroughs could spark.
Which leads to a really interesting question to chew on, I think. Looking at the big challenges we face now, what seemingly impossible problems feel like they're maybe ripe for that kind of innovative leap in the next 50 years?
Yeah, what are the really pressing unmet needs today?
Or, thinking about these 25 again, beyond just vision and execution, what other common threads pop out? Is it how ideas increasingly jump between fields? Or maybe how access to powerful tools like computing or biotech is becoming more democratized?
Definitely lots to think about there. What connects these dots? Fascinating stuff to ponder.